Okay, good morning, guys. So today, since we are all at home, we're actually going to take a little break from the word problems, right? We'll get back to that tomorrow with the final lesson. So what we're going to do today is we're going to talk about something different, which is determining whether a relation is a function, which should be pretty quick, should be pretty easy. We're not using any real math per se. It's almost more of like a logic type lesson, right? Can we figure out whether this is or is not a function? So we're not using calculators or really very much math, right? It's more kind of following vocabulary and following rules. So speaking of vocabulary, let's put just this first part in our notes, right? So let's talk about this. What's a relation? A relation is just a bunch of ordered pairs. So I could just make up any numbers, right? 5, 12, 3, 74, and negative 5, 2/3, and that would be a relation. Now, a function is a special type of relation. So a function is what we call a one-to-one relationship. So it says exactly one output for each input. Well, let's talk about what those words mean. Well, an input are our x values, and the outputs are our y values. So in this case, our age is our input and our y is our output. So again, this is a one-to-one relationship. Each input x should have exactly one output y. And that's the case here, right? If x is 10, y is 62. If x is 12, y is 70. If x is 40, y is 70. If x is 80, y is 68. Okay? None of the x values are repeated, and that's kind of like the informal definition of a function, okay? But in general, we want each x to have one y, right? We don't care that the y value is repeated. It would be a problem, though, if the x value is repeated. That makes something not a function. So each input, each x, has one y. And I'll illustrate that over the course of a few examples. This is one of those lessons that we look at it the first time. Some of us get it right away, and some of us are like, I don't have any idea what this guy's talking about. And then once we do a few of them, we're like, wow, that's actually really easy. Okay, is this relationship a function? Well, let's see. Well, when x is 1, y is 5. When x is 3, y is 20, but also when x is 3, y is 35. So this is a problem, right? Our function says each input should have exactly one output, right? So when the input is 1, the output's exactly 5. But what happens when the input's 3? Well, when the input's 3, we get an output of 20, but we also get an output of 35. So is this a function? We're going to say no. And the explanation would be the input of 3 has two different outputs. And that's the way we're going to be able to explain our work. Let's look at the next one. Is the relationship a function? Well, let's see. Negative 1 goes to 4, 1 goes to 6, 2 goes to 7, 4 goes to 9. Yes, this is a function. Right? Why is it a function? And your explanation is always the same. Each input has exactly one output. All right, again, as we see more of these, I think they'll still start to maybe make sense and sink in a little bit more. And again, as always, guys, if I'm going through it too quick, you have it on Edpuzzle, just pause it, right? Go back. So let's see. So I've got 4, right, goes to 3, okay. I've got negative 3 goes to negative 3, but I've got a problem here, right? My input of negative 2 goes to negative 1, but it also goes to 4. Is this a function? No. Okay, why? The input, negative 2, has two different outputs. All right, let's take a look at the next one. Negative 4 goes to 5, 2 goes to 12, negative 1 goes to negative 3, and 1 goes to 5. Yes, this is a function. Each input has exactly one output. All right, so yeah, someone will raise their hand and say, wait, so you're saying if the x value is repeated, then it's not a function, and if all the x values are different, then it is. And I'm going to say, yeah, that's not the formal definition, but it works, right? So that's probably what most of us are going to do. All right, guys, so then go ahead. You're going to do your now try, and we're going to determine whether each of these is a function. All right, so let's take a look. So for the first one, I have 7 goes to 2, negative 2 goes to 4, 3 goes to 4, negative 1 goes to 9. I don't care that the y value of 4 is repeated. Okay, each input has exactly one output. We're going to say yes. Now let's look at what this would look like on a graph. All right, so I've got my 7, 2. I've got my negative 2, 4. I've got my negative 1, negative 9. And I've got my 3, 4. So a bunch of kind of scattered points here. All right, let's take a look at the second one. Is this a function? Well, hopefully we found those values and we said no. And we said the input of 6 has 2 different outputs. It's got 6, 7 and it's got 6, 4. So we're going to say, well, what would that look like on a graph? All right, well, let's take a look. So there's my negative 3, 0. Here's my 6, 7. Here's my 6, 4. And my negative 4, negative 11 somewhere down there. So where are these points? Well, it's 6, 4 and 6, 7 are here. So what do we notice, right? Looking at the first graph, I just had a bunch of kind of randomly scattered points. Now my second graph is also kind of randomly scattered, except what we notice is I've got 2 points that align vertically. And more specifically, those are the points that make this not a function, which makes sense because if 2 points are on the same vertical line, it means their x-coordinate is the same and their y-coordinate is different, which is exactly our definition for what makes something not a function. The same x but 2 different y values. So that means if somebody gave us some points on a graph or even a graph itself, we can use this definition. This is what's called, and this is how we derive what's called the vertical line test. Okay, so this is something we're going to grab in our notes, right? So put this on pause so you can get it in your notes. What does the vertical line test say? Well, the vertical line test says, like we just looked at, if I can find 2 points that align vertically, then this is my proof that this is not a function. Whereas here, I don't have anything on the same vertical line. So that is a function, and that's what we're going to apply. So again, you're going to pause it and put it in your notes, and then we're going to take a look at 2 simple examples. All right, let's look at the one on the left. Well, if I make a vertical line here, it passes through 1 point, right? 2, 0, let's say. And I don't even need to record the points, but I'd like to illustrate this. What if I make it here? Well, it's got 0, negative 4. And what if I make it, let's say here, I've got negative 3, 1. And I can make more and more and more vertical lines, and I'm never going to see one that passes through 2 points. So is this graph a function? I'm going to say yes, right? I'm going to say it passes the vertical line test. All right, and we'll look at the second one. And the second one we're going to see is going to fail it pretty quickly, right? What's going to happen, let's say, I don't know, here. Well, I've got these 2 points. I've got, I don't know, 1, 3.5, doesn't really matter. And I've also got 1, about negative 2.5. Now, do I care exactly where those points are? No, but what I care about is they're on the same vertical line, which means they have the same x value with different y values. So this is going to be a big no. This is not a function because anywhere I can draw a vertical line, and I can do it, I only need to do it once, but I can do it again here. I can do it an infinite amount of times technically. I've got negative 2, 2.5, and I've also got negative 2, like negative 1 3/4. Okay, so again, if a vertical line passes through more than 1 point, that means we don't have a function because those 2 points by definition have the same x-coordinate but different y-coordinates. So let's look at that application on a graph. Is it a function? Okay, well if I make a vertical line here, and let's say here, and let's say here, well wherever I make those vertical lines, it's only going through 1 point, so I'm going to say yes, this is a function. Let's look at the next one. Now, if I go right here, not only do I have 2 points, but I have 3 points, okay? So absolutely, this is going to be not a function because it failed the vertical line test. I've got negative 3, 2.5, negative 3, negative 1, negative 3, negative 4, let's say. How about the next one? Well, a circle is the classic example of not a function. So I apologize, my lines aren't vertical. If I put a ruler on here, it kind of freezes up, but clearly I've got a point here and a point here. And if you wanted a little maybe clearer, because that's pretty sloppy, I can do it here. I only need to do it once. I can do it here. A circle is never going to be a function. A circle, an oval, because if I draw a vertical line, I'm going to always go through 2 points unless I do it right on the edge. But we're not really concerned about that. All right, and let's look at the last one. Well, wherever I draw my vertical line, I get 1 point, I get 1 point, I get 1 point. So that's going to be a big yes. So again, with ordered pairs, with the table of values, if the x value is repeated, we're going to say no, it is not a function because the input has two outputs. In a graph, it's pretty easy. Draw up some vertical lines. If none of your vertical lines go through more than 1 point, then we're happy. We say yes, it's a function. And if they do, you're going to say no, it's not a function. Okay, so there's your now try on the vertical line test. So you're going to pause it, and for each of these, you're going to say yes or no and why. All right, so the first one, wherever I draw my vertical lines, I only pick up 1 point. So we're going to say yes, this is a function. I can go down here. Sorry, let me label these. So I'm going to call this number 1, number 2, number 3, number 4. All right, so I already started number 1 for you. So you should be able to do 2, 3, and 4. So for number 2, wherever I draw my vertical line, I only go through 1 point. So we're going to say yes, that's a function. Number 3, if I go through over here, I go through multiple points. Right? 3 of them actually, I only need 2. So we're going to say no, that is certainly not a function. And as I even referenced earlier, a circle and oval, these are not going to be functions because if I draw my vertical line, it passes through 2 points. All right, so the homework is going to be the attached, in addition to the Ed puzzle answering the questions, which we did already, the homework is going to be the attached worksheet. You don't have to print it out, okay? You don't have to do the riddle. You're just going to give me a yes or no for each of them.